In this video, I'm going to show you how I carved these pieces on my CNC machine with only one extra motor and all free software. Let's get to it. So if we think about hardware for a minute, the only things that we really need are a motor and a way to attach the wood to the motor. So for the motor, I'm just using a plain NEMA 17, and you can get fancy with the belts and the setup, and you can put a chuck on it, but the only things that I'm doing is I'm using a little coupler with set screws. And I'll put one side on the motor, and then the other side will go onto a tenon that I cut into my stock. And I cut it on the lathe, but you could also just drill a hole and glue in a bolt or do a number of things. And then finally, I just have a tailstock. So this tailstock will go opposite from the motor, and it'll just keep the wood straight. And the only important things about this are the center height is the same as the motor center height, and it has a little pin in the middle, a little 3D printed spike that'll fit into the hole of the stock. And you can get way fancier with your setup here, but this worked perfectly fine for me. Okay, so now I'm just going to use some blue tape and super glue to attach everything down to my spoil board. And the only thing that I want to watch out for is making sure that it's pretty straight and in line with this axis, the x-axis. Now we can do the electronics, and the only thing that I really changed was rewiring a couple of the motors. And my wires are a little bit of a mess, so I have this picture. And I basically just unplugged both my Y motors and then replugged in the rotary axis into the same place. And the only thing you want to be careful of here is to make sure that you do it while the power is off, because it can burn out the motor drivers if you don't. Okay, so now we're pretty much done with all the hardware and electronics part, so we can move to the software. And in this project, the software is a little bit more complicated, but I want to do my best to give you an overview. So let's say we want to make toolpaths to cut out this knight. The hard part is that this knight is on a rotational axis, and generating toolpaths for that in most traditional three-dimensional CAM softwares is impossible. So what we need to do is make this rotational axis into a linear axis. The way that I'm going to do this is by physically unwrapping the 3D model around its center. And using this method, we can then generate flat three-dimensional toolpaths and then remap the y-axis to the rotary axis. So whenever the machine tries to move in the y, it'll actually just rotate. And that's pretty much it. The only other thing that we need to understand is to tell the machine how much rotation to do for every y step. And this is using the steps per millimeter command. And it's just following this pretty simple formula. It's how many steps it takes your motor to make a full revolution divided by the circumference of your stock. So most motors use 200 steps per revolution and then 16 microsteps, but you can check your own motor. And then it's 2 pi r, so just the circumference of your stock. And your r is wherever you set the origin above the center of the motor. And then this gets you this kind of magic number that we can then use a M92 command. And this just in the Gcode file. And this just tells your firmware how many steps per millimeter on the y-axis it should be. And if we think about it, this really makes sense because we want this long line on the top of the stock. We want this pass to go all the way around the stock. So using this method, we can unwrap the object and then generate flat toolpaths and then use this command to make everything work. Okay, so now in Blender we're going to unwrap the object. And Blender has a little bit of a learning curve. It's mostly used for animation, but you can also use it for manipulation of mesh and vertices like I'm doing here. So it's pretty simple. You just import the model and then rotate and scale it, apply transformations, and then run the script that I found, and the script flattens it all. I have a video explaining in a bit more detail what I did, and it also has a keylogger if you get stuck. Okay, so now that we're done unwrapping the mesh, we can go ahead and start generating Gcode. So I'm going to be making all my Gcode, all my toolpaths in Fusion, but you can use whatever software you want. So first, I'm just making a virtual stock. It's a box that corresponds to my stock, and its Z height is the radius of the stock. It's actually the height above the center of the motor that I'm going to be setting the origin, but it's about the radius of the stock. And then my X length is just the length of the stock. And then my Y height is the only tricky one. It's the circumference of the stock, or 2 times pi times the radius. So now I'm just going to go ahead and insert the mesh under insert mesh, and then rotate it so that the y-axis is with the rotary axis that we just unwrapped. And then place it inside your body, your mesh, trying to make sure that nothing sticks out and that it all fits inside. If you need to, I didn't need to, but if you need to scale, just scale proportionately on the x, y, and z until it fits in the x and z. And then this gap here on the y we need to get rid of, so we want to scale disproportionately on the y-axis so that it just hits the circumference. Now that we have the stock and body scaled to the dimensions that we want, we can go ahead and go into manufacturing to start our toolpaths. So first I'm just making a setup, and under stock I'm defining the box that we made as the stock to use, and then I'm making the origin. It can be any of these points, it doesn't really matter, but one of the top 3 on the left is what I like. And then for good measure I'm just selecting the mesh as the body. And now for toolpaths, you can do whatever you want. You know your machine tool. I'll put my toolpaths on the screen now. Once all of your toolpaths have generated, go ahead and post process like you normally would. I like to do this into 2 files, one for all my roughing and then one for my finishing toolpaths. And then open up your Gcode into a text editor, and in the setup, or the start begin in this case, go ahead and paste that M92 command that we made earlier. And this is what makes everything work. This is what controls the Y's steps per millimeter. And then after that, just save the file and you're all ready to go. Now I'm at the CNC and I moved the bit to where I want it. The whole machine is along the x-axis, and the bit is at the z height, the radius height, above the center of the motor. And then I just reset all the coordinates and started the machine. And we have success. I didn't get a video of all of the cutting, but as you can see from these pictures, the toolpaths perfectly wrap once around the stock. And there we have it. As you can see, it looks pretty good. I'm excited about how it turned out. All the details came out pretty well with the finishing pass. And this whole process can be replicated for any number of things. I'm pretty excited because it'll work for busts with good detail and any other game piece or 3D model that has one axis of symmetry that you can think of.
Alright guys, I hope you liked that YouTube video. Smash that like button if you enjoyed this video, and don't forget to subscribe.